Hello, dear friends, viewers of Booty Aviation Training. Welcome back. Today in the Aviation Tidbits, we are going to study what are all the factors which produce the lift or the lift formula. And when we are trying to increase the lift, what else happens? Does the drag also increase? Okay, that's what we are going to discuss today. And just a reminder, like and subscribe to my channel for many more such aviation tidbits coming up by yours truly, SK Booty. So here we are with the total lift. What is the formula? We had studied earlier that lift counteracts the downward force called weight, and in a straightened level, lift is equal to the weight. And stand by for forthcoming lessons in which we will find out, is the lift always equal to the weight? If not, when is it less than the weight and when is it more than the weight? In today's lesson, lift is upward reaction obtained by changing direction of the moving stream of air by the wing called the aerofoil section. As the airflow hits the wings, some part of the airflow goes on the upper surface, other passes through the bottom surface. Upper surface airflow velocity increases, pressure decreases. Bottom surface airflow, the pressure increases, and this difference in pressure gives the lift, upward reaction. And the lift acts at 90 degrees to the relative airflow or the flight path. The relative airflow comes from the opposite side of the flight path, right? And this point, lift, acts on a point which is called center of pressure, and this point is on chord. Total lift is coefficient of lift into half rho v square s. Coefficient of lift depends upon the camber and the angle of attack. Rho is the atmospheric density, v is the true air speed, and s is the surface area. Now you will realize that surface area once made is made, cannot be changed in the air. Camber also cannot be changed in the air. Density is not in your hands. Then what is in the hands of the pilot to increase or decrease the lift? It's a speed and the angle of attack. At a higher angle of attack, you can obtain the same lift at a lower speed. Higher the coefficient of lift, lower is the speed at which given lift can be obtained, and at very low speeds. For example, during final approach for landing, the lift can be augmented by using flaps, slats, and slots, etc. Now, the drag formula is also coefficient of drag into half rho v square s, and coefficient of drag is also proportional to camber and the angle of attack. Now, here comes a problem. When you increase the lift, the drag will also increase. And for any given engine power, the speed of the aircraft depends upon the drag. So here's your lift, 90 degrees to the flight path. Weight always acts vertically downward. Drag opposite to the flight path, and thrust is in the direction of flight path. Now, to generate the lift, there must be a pressure difference between top and bottom surface. And the the zero lift angle of attack. To give the pressure difference, we give an angle of attack. Zero lift angle of attack in a symmetric aerofoil is 0 degrees, and at -3 to 4 degrees in asymmetric aerofoils, no pressure difference is created. But even at 0 degrees angle of attack, coefficient of lift is positive in cambered, which are called asymmetric aerofoils. Now, the question will be asked is, what angle of attack should I maintain to get the maximum lift? When we compare the graph, which I'm not showing you here, just remember these figures. At +3 to 4 degrees angle of attack, the lift is 12 to 20 times or even 20 times the drag. Very nice. Now, beyond this angle of attack, the lift increases, but drag also increases. And drag increases at a higher rate. So much so that at around 15 to 16 degrees angle of attack, the lift is to drag ratio is very low, just about around 5 times. And this is the time the aeroplane stalls, and this angle is called stalling angle or Burble point or critical angle of attack. Now, when we fly, we do not maintain an angle of attack which will give us maximum lift. We also don't fly at an angle which will give us minimum drag, but that angle of attack, which is roughly +3 to +4 in most general purpose aeroplanes, which gives the maximum lift is to drag ratio. And just to tell you another fact, that is the angle of incidence of the aeroplane. So when your airflow is meeting the fuselage at a 0 degrees angle of attack, the wings, because of the angle of incidence, are meeting the airflow at a positive angle of attack. Now, you might ask, do I have to remember all this? Yes, of course. If you want to pass the exams, you will have to remember. And many more such lessons will be coming up. Useful lessons will be coming up. So, for the time being, for today, I will say bye-bye to you. And before you switch off or log out, please wait for a few seconds, subscribe and press the bell icon to remain updated on latest videos. Happy landings, keep smiling, and make some new friends by sharing the channel link. Bye for today, till we meet next. Okay, happy landings.